Hello. Here we are going to talk about the difference between a data analyst and a data scientist. So, who is data analyst? So, here we are going to talk about this particular topic with two simple example. So, the data analyst is a person who had the ability to analyze a given data. So let's say we are giving some data, some numbers, 5, 3, 7, 10. Okay, with this set of numbers, that is data, a data analyst person can analyze the data and give some results over that. So that is a job of a data analyst. So to become a data analyst, the first thing that is expected is a experience in statistics. So a person with a master degree in statistics is always preferred to be a good data analyst. So if you're not a statistic person, it is going to be very difficult to become an expertised data analyst. Okay, so you may be working with a little data in Excel and using very simple functions, statistics functions like average, mean, mode, standard deviations, but that is not the entire statistics, right? So if you want to become a data analyst, it is expected that you are holding a master degree in statistics. So that is called the data analyst. So what is meant by data scientist? So data scientist is a person who can also looks at the data, but in addition to a data analyst, okay, a data scientist has the knowledge about the environment in which he is working on. So that is an additional advantage a data scientist is having. So a data analyst, by just looking at the data, can able to understand and identify the risk and challenges involved in that particular data for a given scenario. So data scientist is extremely far better than a data analyst. So in a normal scenario, a data analyst works under the data scientist. Okay, so now we will see with a simple example on how to understand how a data analyst works if some data is given, or how a data scientist actually handles a data when a scenario is given to him. Okay, so let's start. Okay, so here is the scenario 1. Here we have two person A and person B, standing at one side of the pond. Okay, and both of them have to cross the pond to the other side. So the constraint is only the person A knows how to swim and person B doesn't know how to swim. So to understand the depth of the pond, person A decides to swim and go to the other side of the pond. Okay, so the person A just swims across the pond, and on the way he noted down the depth of the pond in this sequence: 1, 1, 5, 1, 1. Okay, so the person B, once he reaches the other side of the pond, person A, he informs the person B that the depth of the pond was in the sequence of 1, 1, 5, 1, 1. Okay, so this is a typical example. Okay, now you may be feeling that hey, now I can see that the depth of the pond is 11511. So the average height of the maximum height of the person of both A and B is only 5.5. So when we just look at the data and the environment, and the question that comes in, the question is whether the person B can cross the river. It's very obvious that we can, just looking at the data, by just looking at the environment, we can very well say it is possible for person B to just cross the river. Is that right? That means if we are able to find the right solution by just looking at the data and the environment, and we can answer the question, we can be termed ourselves as a data scientist. Okay, so here in this case, since the environment is very obvious and it's very simple example for everyone, I think everyone can say that it's possible for person B to swim. So we can say ourselves that we are all data scientists for this particular scenario. But it's actually, this is not the case, because there might be some different scenarios where we do not know what is that kind of environment, and still we have to do some logical decisions. So that's where data scientist is little it's not an easy job. Okay, so now let's consider this person B who got the data from the person A, that 11511. Okay, this is the data he has received. So let's say person B is a data analyst. Okay, he is a good statistics person. Okay, so based on the given data, he tries to do some statistics. So what he finds is, he calculates mean, median and mode, and he finds that all the values are less than his height 5.5. So that means that he believes that based on these calculations, he finds that there is no risk of crossing this pond. Is it enough? That's the biggest question. Actually, for this scenario, we know that there is no risk, because he is 5.5, the maximum depth is only 5. So we obviously know the answer, but just look at the data, and is it enough? That's the first question. So based on the statistics, it's not enough to take such a decision, okay, whether to cross the river or not. We will see one by one how it is incorrect. Okay, so now based on this particular information, he believes that he can cross the river. Okay, now data analyst wants to go further, and he wants to calculate the variance and the standard deviation as well, just to understand whether what is the numbers that he is going to get on the variance and standard deviation. Okay, now here, by just looking at the variance and standard deviation, he finds that the deviation, the standard deviation it's very high. So when the standard deviation is 0, it means that there is no much deviation in that given data set. Okay, so now here he sees that the deviation is very high. By just looking at this data, a data analyst assumes that it's a very high risk to cross the river now. How crazy! So now, when in the previous scenario, he believes that he can actually cross the river. Now, by just looking at the standard deviation, now the same data analyst believes that he cannot cross the river because there is so much of deviations in the given data set. Is it the right way? Is it the right decision, or is it enough? That's where the question comes in. So data analyst may be good in actually doing the statistics. Okay, he can use the statistics formulas, and he can actually use and gets an output, but whether he is good enough to take a decision about that particular environment is a questionable. So now let's consider a data scientist. Okay, now let's say this person B is a data scientist. Okay, now because he is a data scientist, okay, what he has done is, let's assume that he has already calculated mean, mode, median, variance, standard deviation. Still he goes further in further calculations, further statistics methods, and finally he finds that, okay, let's consider a bar chart. He's creating a bar chart, and he identifies that there is a maximum depth of 5 feet in the pond. It's a very simple data. By just looking at the graph, he finds that this particular scenario, in this scenario, there is no risk. There is no risk of crossing this pond. So person B, as a data scientist, he takes a right calculation, a right decision by looking at the bar chart for this scenario, and he takes a call. Okay, so hopefully you can understand how a data scientist works and how data analyst works. Now let's look at the scenario 2. Okay, now let's take the scenario 2. Here also, the person A and person B stands at the one side of the pond, and the person A agrees to swim across to the other side. And now in this scenario, person A actually identifies that the depth of the pond in the sequence of 1 1 6 1 1. Okay, so now by just looking at these numbers, you may feel like oh, there's a definite risk that person A will definitely die if she crosses across the river, because the height is 5.5 and the depth of the pond is 6 feet. So there's a definite chance of losing the life. Okay, that means you are again a data scientist, because by just looking at the data, you are able to understand the environment as well, and you are able to understand the question. So all these three, if it falls under, you are a data scientist. Okay, so now here is the same scenario again. The person A, let's assume that she's a data analyst. Once again, the person B calculates mean, mode, and median. Again, by just looking at the output of these data, again the person B finds that there is no risk, because all the values are less than 5.5, and believes that there is no risk. And if the person B is a data analyst, she will tell that there is no risk, just go and cross the river. So what is the impact? She will die. So the data analyst may be a good in doing data analytics, statistics, but may not be the right person to give a kind of decision, because data analyst doesn't know the specifics about the environment or able to understand the question that comes over this particular scenario, right? So as a data analyst, okay, the person B just goes further again and also calculates variance and standard deviation. Compared to the previous scenario, the standard deviation is less, but still it is having a very high deviation, right? It's 1 point, it's more than 0. So again, by just looking at this data, now the person B highlights that there is a risk in crossing the river, which is true, but is it the right decision? Because if you look at the previous scenario, the same decision was being given by looking at the standard deviation, right? Where there is no risk for the previous scenario, person B, who's a data analyst, said there is a risk of crossing the river. Again, in the scenario 2, by just looking at the standard deviation, person B believes there is a risk. Of course, in scenario 2, there is a definite risk. But is it the right decision, or is it a right parameter? Standard deviation is the right tool to take a call about this particular scenario? No. Okay. So data analyst can actually go wrong with the decisions. Now let's assume that person B is a data scientist. So data scientist calculates all the same statistics formulas: mean, mode, median, variance, standard deviation. Still he believes this is not the right tools to give a clear decision. So he goes further for this scenario and go to the bar chart. Now in the bar chart, person B identifies that The depth of the field is showing as 6. So it's a high risk. Now the person B, as a data scientist, confirms that this scenario is definitely a high risk. So there is no way that a person B can swim across the river. Okay, so this is a simple example. Hopefully I think everyone can understand the difference between the data analyst and the data scientist. Data analyst is maybe a good in statistics, but he may not be a right person to take any decisions if the person doesn't have an expertise on the environment and the question related to that. A data scientist need not be a data analyst, but if he is good in understanding a data and the environment and the question, he can be a good data scientist. But he can be a specific data scientist for specific environment only. But if a data analyst who is very good in data, that is statistics, a master degree in statistics, PhD in statistics, if that person become a data scientist and able to understand the environment and able to understand the question that comes from that, he can become an expert, and I think he is the best data scientist you can ever get. Okay, and in IT environment, if you are a very good statistics person, you can learn Python, and that Python will give so much options to actually do data analytics and reporting and visual presentations. So that's the way the IT field works in this data analyst and data scientist world. Thank you for watching.